So first let us see what is this spanning tree, and then we'll go with the construction of this spanning tree. So a spanning tree is a subgraph. So we all know about the graphs. So graphs are nothing but connected nodes with the edges with the cycles, right? So it is, the spanning tree is a subgraph of a graph with the vertices and edges. So a graph will be having the vertices and edges with the cycles, right? But here the tree means it's a subgraph with no cycles. With no cycles. So here if it is not having any cycles, we call it as a tree, right? Now, so we need to follow a few points or a few rules while constructing this spanning tree. The first one is, so the spanning tree should connect all vertices of a graph, right? So it should contain all the vertices which are available in the graph in the spanning tree. And the second one, if graph is having n vertices, then the spanning tree should have n minus 1 edges, right? So n vertices in the graph, then spanning tree will be having n minus 1 edges. And the third one should not contain any cycles. So we need to follow these rules while constructing the spanning tree, right? So let us take one example. So graph, and we'll see how to construct the spanning trees. So first we'll consider the graph, and then we'll construct the spanning trees from that particular graph. See, so we have to follow all the rules, right? So let us take an example with the 4 nodes. So A, B, C and D. So these are the 4 nodes, and this is a connection between all these nodes. So this is a graph, okay? So edges, vertices and cycles, right? So now we should construct the spanning tree. So what is the first rule? First rule is number of vertices should be equal. Number of vertices must be equal in both the graph and spanning tree. So we have to connect all the edges. We need to connect all the edges. So I am writing all the edges here. Next, so these, if there are 4 vertices, we should connect with 4 minus 1 edges. So I will connect this one. So A to B, A to C and C to D. So this is a construction, right? So you can observe here, here we are having a 4 vertices and the edges are 4 minus 1, that is 3 edges. So this is one spanning tree. And another case, let us see, A, B, C, D. So let us consider this one. So this is also a possible spanning tree from this particular graph, right? So because all the edges, all the vertices has been connected, and the number of edges are n minus 1, that is 4 minus 1, and there is no cycle, right? And one more possibility. So this is one more possibility, right? So here also all the 4 vertices has been connected with n minus 1 edges, and there is one more possibility here. So this is one more possibility. Here also all the 4 edges, 4 vertices has been connected with 3 edges, because we are having 4 vertices, so the number of edges must be 4 minus 1. So this is the cyclic graph, and this is a acyclic graph. Acyclic graph is nothing but our trees, right? So all these are the spanning trees, okay? All these are the spanning trees. spanning trees, right? So one graph can have a multiple spanning trees. So here we can have the four possibilities, right? And if you consider one more example like a triangle shape. So this is a graph. So we are having 3 vertices and 3 edges, so that it's a graph. So this can be constructed as, so A to B, B to C, A to B, sorry, A to C, C to B, right? And A to B and C. So these are all the different possibilities of spanning trees can be constructed from this particular graph, right? So hope you got an idea about this spanning tree. What exactly this spanning tree? Spanning tree is a subgraph from the original graph. So with n vertices and n-1 edges. N-1 edges. Right? So we need to follow the 3 points. One is all the vertices should be connected, and if n vertices are there, n-1 edges should be there, and there should be no cycles. So this is all about our spanning tree. Now, what is the minimum spanning tree? Now let us see the concept of minimum spanning tree. So minimum cost spanning tree. So it is called as a minimum cost spanning tree. So let us consider the graph A, B, C and this one. This is a graph, right? This is a graph. So each edge will be having a cost. Each edge will be having a cost. We can also call it as a weight for the particular edge. Let us take here some 5, some 2, some 3. So the cost of an edge A to B is 5. The cost of an edge from B to C is 3. The cost of an edge from A to C is 2. Now construct the possible spanning trees. So the possible spanning trees are A to B, B to C, A to B, A to C, A to C, C to B. So these are all the possible spanning trees, right? All the possible spanning trees. Give the edges here. So 5 and 2, sorry 3. And here 5 and 2. 3 and 2. So now you have to, so you can observe here all the vertices has been connected. Okay, all the vertices has been connected, and here also all the vertices has been connected, and here also all the vertices has been connected. Right? So here you can see there is an edge A to B, B to C. There should not be a cycle, right? So here it is A to B, B to C. So if you add one edge from C to A, so what happens? The starting vertices and the end vertices same. That means it forms a cycle. So we should not connect this one. So that's why we are not connecting, and this is a spanning tree, right? Now cost for this spanning tree is 5 plus 3, 8, because there are 2 edges with a weight 5 and 3. The cost of this particular spanning tree is 8, and the cost for this one is 7, 5 plus 2. So the cost for this one is 3 plus 2, it's a 5. So you can observe here, for every spanning tree we are finding the cost. So here the cost is 8, cost is 7, cost is 5. Now we need to select the minimum cost spanning tree. So we will select the minimum cost spanning tree. That means the tree with a minimum cost of edges, right? So minimum weighted edges. So here there are 2 approaches to find the minimum cost spanning tree from a graph. So that is, one is a Prim's algorithm, another one is a Kruskal's algorithm. So in today's session we'll discuss about the Prim's algorithm. So before applying the Prim's algorithm on the graph, make sure that the graph should be weighted, connected and undirected. So unless the graph is weighted, connected or undirected, so we can't apply the Prim's algorithm. So make sure the first point before applying the Prim's algorithm. So the graph should be weighted, connected and undirected. And coming to the steps. So first we need to consider any vertex, because so we know the spanning tree definition. Spanning tree is a subgraph from the graph without any cycles, consisting of all the vertices of a graph, right? So consider any vertex of the graph. And the second step, find all the edges from the selected vertex to all the new vertices. So find all the edges. So among all the edges, you need to select the least weighted edge. So among all the edges, we need to find the least weighted edge and include it in a tree. So we need to construct a tree for that selected vertex and give in the least weighted edge. And if the least weighted edge forms a cycle, so if you include this least weighted edge into a tree and if it forms a cycle, then simply discard. So if it forms a cycle, then simply discard that one and consider the next least weighted edge. So once you find the least weighted edge, you have to include it in a tree. So after including it in a tree, if it forms a cycle, simply discard that one and consider the next least weighted edge and include it in tree. And the third step, repeat the same step 2 until all the vertices are included in a tree. So once all the vertices are included, automatically that will be the minimum cost spanning tree. Right? So this is how we need to find the minimum cost spanning tree with a Prim's algorithm. So here now we'll see an example and we'll find the minimum cost spanning tree by following all these rules. So let us take an example. So consider one graph. So consider this graph. So let us take some weights. So let us take these weights. Okay, this is a graph. Consider this graph. And we need to find the minimum cost spanning tree for this particular graph. So what we have to do, first consider any vertex. So I will consider A. I will start with A. So this is a A. So I have included this one in the spanning tree. Now consider all the edges from A. So you can see A to B with a cost of 2 and A to C with a cost of 3. Right? A to B with cost 2, A to C with cost 3. So we need to select the least weighted edge because A is having two edges. One is from A to B, one is A to C, A to B, A to C. So consider the least weight. So this is the least among these two. So we need to add this B to the spanning tree. Now the spanning tree will be A followed by B. So with a cost 2. So this is the tree. This is the tree. Now what is the new vertex here? B. So what is the remaining vertex? Consider this one A to C with 3. And consider the edges from B, right? So from B, there is a vertex from B to A, which is already covered, right? Because this is a undirected. Okay, this is a undirected. So B to A is covered. So we need to consider B to C and B to D. So B to C with a cost of 5 and B to D with a cost of 3, right? B to A, B to C, B to D, right? Now, what happens? Among this one, we are having a two edges with a minimum cost 3. So you can select any edge, no problem. So I will select this one, B to D. I will select this one, B to D. Now the tree will be A, the tree will be A followed by B, B to D. So the edges are 2, 3. Now the spanning tree becomes this one. So in the first step, the spanning tree is this one. That means only one vertex. In the second step, so first step, second step, and this one is the third step. Now consider the remaining edges. What are the remaining edges? A to C with a cost of 3, B to C with a cost of 5. Right? Now D is added here. Now consider the edges of D. So you can see D to B, which is already done because of undirected, right? So you can simply use this one bidirectional. right? Right. So B to D is completed. Now B to E, D to E. So D to E with a cost of 2 and D to F with a cost of 3, right? So the edges of D are D to B, D to E and D to F. So among the D to B is completed, right? Now among these, what is the minimum cost? So this one, least edge, least weighted edge. So consider this one. Now the spanning tree will be A, edge to B, edge to D, and from D to E. So the cost is 2, 3 and 2. Cost is 2, 3 and 2, right? And next, what are the remaining edges? Simply write here A to C with a cost of 3, B to C with a cost of 5 and D to F with a cost of 2. Now E is added. So what are the edges of E? E to D, E to C, E to F. So E to D is completed now. Just discard that one. E to C. So E to C is not there. So we can write the edge E to C with a cost of 4 and E to F with a cost of 5. E to F with a cost of 5. E to F, right? Now among this one is the least weighted edge. Least weighted edge. D to F. So see, our graph, our tree will be A, B, D, E and F, right? So this is 2, weight 3, this is again 2, now again it's a 2, again it's a 2, right? You can observe here whether all the vertices have been covered or not. A, B, D. So there is no, C is not there, right? So you can continue the process. So what are the remaining edges? A to C with a cost 3, B to C with a cost 5, E to C, D to F is completed. So E to C with a 4, E to F with a 5, right? Next, F, we have reached to F. So the new vertex is F. So write down the vertices of F. So F to D, F to E, right? F to E is completed. So F to D with a cost of 3. Now you can see among all these things, what is the minimum? A to C or F to D, right? F to D is also completed, right? F to D is also completed, so you need not go with this one. And one more thing is F to E. So that is also completed. F to E, we have written F to E here, right? So now among all these things, what is the minimum cost? A to C. So consider A to C and observe whether it is giving the cycle or not. It forms a cycle or not. So if you apply A to C, it doesn't form a cycle. So consider this one. So A to B, D, F, E, C. Right? Now you can give the weightage 2, 3, 2, 2 and 3. So you can observe here A to B with 2, B to D with 3, D to F with 3, D to F with 3. So D to F 3, okay, D to F is with 3. So this is D to F with 3 and then D to E is 2 and A to C is 3. So you can observe here all the vertices have been constructed, that means included in the tree. So A, B, C, D, E, F. So here we are having total 6 vertices. 6 vertices. So all the 6 vertices have been included. And now you can observe here the remaining edges. What are the remaining edges? So consider B to C with a 5 and E to C with 4 and E to F E to F with a 5. So if you consider B to C, so if you add a B to C, it forms a cycle. So we have to discard this one, right? E to C4, E to C. If you just connect this edge, again there is a cycle. So A, B, D, E, C, A. So again you need to discard this edge. And E to F, again if you connect this edge E to F, again a cycle forms. So again we need to discard these edges. So we have to discard these edges so that we can have this one. Okay. So hope you got this one. So I think these things are not clear. So I'll write the edges here. E to C with a 4 and E to F with a 5, right? So I think now it's clear. So we have to apply, we have to consider from the single vertex. You can consider any vertex and consider the edges, all the edges from that vertex to new vertices, and consider the least weighted edge. Okay, and continue the process until all the vertices will be connected. So this is the spanning tree, minimum cost spanning tree, for the given graph. What is the cost here? So you can observe the cost. I will write here. Cost is equal to, so what is the cost? 3 plus 2 plus 3 plus 3 plus 2. 3, 2, 3, 3, 2. So what is the total cost here? You can observe. So 5, 8, 10, 13. So 13 is the minimum cost for this particular tree. So the cost is 13. The cost is 13 to construct this particular spanning tree. So this is the procedure we need to follow for Prim's algorithm. Okay, so consider a graph and finally we are getting the minimum cost spanning tree. So we'll get a many spanning trees from this graph. So as we discussed in the previous session, right? So we can get a many spanning trees from this graph, but we need to find out the minimum cost spanning tree. So this is the minimum cost spanning tree obtained from this particular graph. So let us consider this graph, and now we are supposed to find out the minimum cost spanning tree for this particular graph. So just recalling the steps, the first step we can consider any vertex, and the second step we need to find out all the outgoing edges from that vertex to new vertices and consider the least weighted edge and include it on a tree. And after including the least cost weighted edge on the tree, if it forms a cycle, so we have to discard and we need to go for the next least weighted edge, right? And we need to repeat the same thing until all the vertices are included in a tree. So let's start with this one. So this is a Prim's algorithm. So by using this Prim's algorithm, we are going to find out the minimum cost spanning tree. So first we need to consider any edge, right? So the first step I will go with here. So consider A. Now what are the edges from this A? So edges are like A to D with a 5 and A to F with a 7 and A to B with a 14 and A to C with a 21. So you can see from A we are having a 4 edges, A to D, A to F, A to B and A to C. Now the next step we need to select the minimum cost edge, right? Least weighted edge. So among these, this is the least cost edge, right? So consider this one. So our next one will be A to D. A to D with a cost of 5. A to D with a cost of 5. Now, what are the remaining edges? Simply write down all the edges. So, one is A to F with a 7 and A to B with a 14 and A to C with a 21. Now, consider the edges from D, right? Because the new vertex included in our tree, D, so write down the edges from D. So, two edges are there, D to A already done. So, D to F with 13, D to F with 13 and D to E with 22, D to E with 22, right? So, among all these edges, so this is the first step. So, among all these edges, what is the minimum cost? So, 7, 14, 21, 13, 22. So, this is the minimum cost. So, consider this one. Okay, consider this one. Right? Now, the graph, the tree becomes A to D with a cost of 5 and from A to F. So, the next cost is A to F. So, A to F with a cost of 7. So, what are the remaining edges? What are the remaining edges? See, after this one, what are the remaining edges? You simply go with this one. So, A to B with a 14. Next, A to C with a 21. A to F. So, this already happens, right? Sorry, D to F. Okay, D to F. So, D to F with a 13 and D to E with a 22. So, now we are having a one more vertex, that is F. So, now consider the edges of F. So, from F we are having how many edges? So, 1, 2, 3, 4 and 5. So, among all these things, F to A we have completed. So, F to D or D to F. This is a bi-connected. So, F to D or D to F both are equal. You can simply leave. F to E with a cost of 15. F to G with a cost of 18. F to B with a cost of 2. So, these are the edges from F. So, among all these things, consider the least cost weighted edge. So, among these, this is the least cost weighted edge, right? Now the tree will be A, D, F, B, right? So, this is 5 and this is 7 and this is 2. Now, our tree is like this. Okay, tree is like this. Now, the new vertex added here and consider all the remaining edges. Okay, consider all the remaining edges. So, what are the remaining edges here? So, all these are the remaining edges. A to B with a 14. Next, A to C with a 21. And D to F with a 13. And D to E with a 22. F to E with a 15. Next, F to G with 18, F to B with 2. So, our tree consists of a new vertex B. Now, consider all the edges from B. So, from B we are having only two edges, B to C and B to G and B to C, B to G, B to F and B to A. Now, B to A, so this is already covered. B to F, already covered, right? So, we should not consider this one because we have already done, right? So, this is already done, so we should not consider. So, B to F, there is no edge. So, B to G, 19. So, B to G with 19 and B to C with 15. B to C with 15. Consider the least. Consider the least among all these things. What is the least one? So, this one is the least. D to F is 13. So, D to F is 13. So, if you consider D to F, so it forms a cycle. You can observe here. It forms a cycle. So, we should discard this D to F. We should discard this D to F, because if you add this one, we'll get a cycle. So we should not consider this one. Next least. So there are two edges which are having the next least costed edge. So F to E or B to C. In such cases, you can consider any edge. Okay, here we are having two edges with the minimum cost. You can consider any edge. Okay, so I will consider B to C. I will consider B to C. Now the tree will be like this: A, D, F, B. Okay, so this is 5, this is 7, and this is 2. Now we need to consider B to C. What's the B to C here? Yes, B to C with 15. B to C with 15. Now consider all the remaining edges here. So A of B with a 14, right? So you can observe here. Okay, let us write down. No problem. Next, A to C with a 21, D to E with a 22, and F to E with a 15. Next, F to G with a 18, and B to G with a 19, because we should not consider this one because we have already done the edge from B to C. Now there is a new vertex here included in the tree. Now consider the edges of C. So C to B, there is no edge, right? So C to B, sorry. So already C to B there is an edge, right? So C to A, there is an edge here already covered. C to B already we have constructed in the tree. C to G is 3. C to G is 3. And C to E is 4. C to E is 4. Right? So among 4 edges from C, C to A is already written. C to B already considered in the tree. C to G and C to E. So this is the next one. So we need to select the least cost from this one. So which is C tends to G with a 3. So from C you can construct a G, so which doesn't form a cycle. So now, I will consider here A with a D with a F, B, C and G, right? So the weightages are 5, 7, 2, 15 and the edge is 3 here. Okay, edge is 3. Now we have taken one edge, that is a new vertex G. So what are the remaining edges? See, you can observe here. So A tends to B with a 14 and A tends to C with a 21, D tends to E with a 22, F tends to E with a 15 and F tends to G with 18, B tends to G with 19 and C tends to E with 4. Now the new vertex is G. Now consider from G. So G, we are having 1, 2, 3, 4 and 1, 2, 3 and 4. So first G to F. So is there any edge? There is no edge. So we have to consider G to F. Okay. So let us consider here, right? So G to F with 18. Next, G to B. G to B. There is considered. We have considered, right? G to C. So we have already constructed the tree. So G to E is 2. G to E is 2. So these are the edges. Among all these things, consider the least. So this one is the least, G to E. Now construct the tree with this one. So A, okay, A to D, F, F to B, B to C, C to G, and the last one is G to E. G to E. So the cost, let us write down the cost. It's a 5, and it is 7, it is 2, it is 15, it is 3, and again the last one is 2. Right? So this is the tree, and now you can observe all the vertices has been covered. So A, B, C, D, E, F and G. Right? So all the vertices has been covered here. So we can stop here and consider the remaining vertices. So consider this A to B. So we have considered G to E with the 2 and we have included the edge. Consider A to B. If you consider A to B, it forms a cycle. So we should discard. A to C. If you consider A to C edge, right? Again, it's a cycle. D to E. So D to E. Again, it forms a cycle. F to E. F to E. Again, it forms a cycle. C to G. Sorry, F to G. F to G. Again, it forms a cycle. B to G. Again, it forms a cycle. So C to E. It forms a cycle. G to F, G to F, again it forms a cycle. So all the edges has been covered and all the vertices has been covered here, and now you need to find the minimum cost of this particular tree. So this is the minimum cost spanning tree. So this is a minimum cost spanning tree. So you can see, so we are having all the vertices, okay, we are having all the vertices, and if the graph is having n vertices, the edges should be n minus 1. So how many vertices are there? 1, 2, 3, 4, 5, 6 and 7. 7 vertices are there. So it should have 7 minus 1, 6 edges. So 1, 2, 3, 4, 5 and 6 edges. So it satisfies the spanning tree, and you can apply, you can see this is the minimum cost spanning tree for this particular graph. And here the minimum cost, I will write here, I will write down here. So the minimum cost is, so how much? 5 plus 7 plus 2 plus 15 plus 3 plus 2. So how much it is? 12, 14, 29, 34. So minimum cost spanning tree, the cost of this particular spanning tree is 34. Right? So hope you understood. First you need to select any vertex and consider all the outgoing edges of that particular vertex to the new vertices, and select the minimum or least weighted edge from the among all the vertices, and if that edge forms a cycle in a tree, discard that edge and consider the next least cost weighted edge, and repeat the same process until all the vertices are included in the tree. So here you can see all the vertices are included in the tree. So we have stopped the procedure and we have checked all the edges. So all the edges, if you consider any one of the edge, it forms a cycle here. So that's why we have to remove all the edges. We need to discard all the edges, right? So this is how we can find the minimum cost spanning tree by using the Prim's algorithm. So hope you understood this one. If you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.